Go to screen share. Okay.
Backdrop there.
What is that thing? I got to get rid of that. Okay, that's gone, I think. So you should be seeing, hopefully you see the code check, this plumbing stuff. Yay, nay?
Yes.
Okay.
Yes, sir.
'Cause I don't know if you're there. There's a couple things in the plumbing code that we haven't talked about at all. One is roof drains. If this thing stop. I think. So we talked about this table 13 last time. That's on specific types of fittings. So there are some that are allowed in the IRC that the Uniform Plumbing Code doesn't allow you to use. So California, the plumbing provisions were not adopted from the IRC, so we are straight Uniform Plumbing Code. And my computer, of course, is behaving strangely again. We have some other issues to deal with. One of them is if you're below the sewer, the public sewer, or below the upstream manhole. The concern is if a manhole gets plugged up, the sewage can back up to the street level. And at that point, if you're below the street, you can get sewage back into the building. And so there, if that's the case, you need some sort of a backwater valve to keep that stuff from backing up. And that's what this thing is talking about here on the far right, fixtures below manhole or sewer. And another reason why it's always good to live a little above the street than a little below the street. So normally the sewer is buried 3 to 5 feet below the street level. In some parts of town, it may be as deep as 20 or 25 feet. Normally don't like to put it that deep because it's expensive, and if you have to dig it up again, it's a problem. But there are some places, if you're trying to avoid putting in a pump station, where you have to get pretty deep if you're going to let gravity do all the work for you. And so if you do have a backwater valve, it needs to be accessible because it can get clogged. And that's what they're talking about there. You shouldn't have any questions, I don't think, on the fittings. They're pretty much the same regardless of the material. But residential, we're normally using plastic these days. Commercial, cast iron. There's a few jurisdictions that allow plastic for commercial, but not many currently. I don't know why I'm getting that little wheel.
What are you getting?
Getting a little wheel.
Oh, you're
yeah, the computer is responding in an odd way tonight, but now also, what happened? Well, that's not coming in either. So let's see. Cleanouts, we talked a little bit about. So the required locations, usually upstream. Some cases we're using the vent. So if you have a continuous vent, you can use that as a clean out. Some cases, private property, 100-foot max is typically what we're looking at. There is an exception there, and that's if you provide a two-way clean out at the junction of the building sewer drain. And we said that the building drain gets renamed and becomes something called the building sewer, 2 feet outside the walls. And why they picked that, I don't know. You also need clean outs if you go 135 degrees of changes in direction. And I think I had a picture of that somewhere, but you can do a 90 without a clean out. But if you go 90, 45, then you're supposed to start putting in a clean out. They're just worried about clogs and plugs. If you live over in North Park, a lot of the old houses over in North Park, the plumbing is actually on the outside of the house.
Yeah.
So which makes it much easier for access. But one
So
of
if
my
it's
pet
so if it's
peeves-
more than 45 degrees, you have to have it clean out. If it's less than, you don't have to.
135 degrees.
Okay.
So if you go every 135 degrees of angle change, you're supposed to provide a clean out.
Got it.
So you can make a 90-degree change of direction without a clean out. But if you then try and go another 90, you're going to have a clean out in there.
Makes sense.
Also, in terms of what's vertical and what's horizontal, if it's not more than 45 degrees from vertical, it's the vertical pipe. If it's not more than 145 degrees from horizontal, then it's a horizontal pipe. And I guess right at 45 degrees, it's probably a horizontal or a vertical. You know, you're kind of right there in the middle, but
So
typically at
if
45
it's more than
degrees,
45 degrees, it's considered horizontal, not
Yeah.
vertical.
Yeah, there's a definition in the plumbing code. I don't think we've looked at the plumbing code too much. Let me see if I can find this.
It's kind of weird. So if you had a 35-degree slant down, it's not considered vertical yet.
Yeah, let me call up
Kinda weird.
that.
Hmm.
Yeah, the internet is slow tonight.
No mask there, GTA. In the car.
Yeah. Let me see, where is that?
Ready to go. I see it.
Oh, I'm trying to find out where that thing is. Waiting for the computer to respond. Okay. All right. Okay, I'm going to abandon this particular line of endeavor. I will send you the definitions for a few things, plumbing, or the vertical and horizontal being one of them. And I'll just ignore that. But said one of my primary complaints about most residential structures is they don't provide adequate clean outs to work on things. So,
Amen.
so
It makes for expensive bills when you're trying to unplug things.
that's true. No, we don't care about that right now. Access, if you put in a clean out, you're required to have access to the clean out, and that includes the clean out shouldn't be too close to the perimeter foundation walls. So you need to be able to get to it. It's supposed to be above the flow line. So
Hmm.
I think I showed you in class, the guy that was putting in the clean outs that were catching the flow.
It's not good.
No, that's not good. So in order for the water to flow, we also need some vents and fixture traps and tail pieces. We talked a little bit about the traps and the trap sizes for that table 12. Trap no larger than well, we don't care about that. The trap seal, which is from the bottom of the trap to the overflow weir, it's got to be a minimum of 2 inches and a maximum of 4 inches. So they do have a pancake trap that's a little flatter. The problem is that will evaporate out more quickly. And if you lose the trap seal, then you can have gas coming up into the building. And usually that's a bad thing. Every once in a while in Vegas, you'll hear about them evacuating one of the hotels because they've had a problem with sewer gas backing up into the building. So primary sewer gases are hydrogen sulfide, which is poisonous, and stinky. That's that rotten egg smell is the hydrogen sulfide. And then methane, which technically doesn't have an odor to it, but it can be explosive in the right fuel air mixture, and it's also toxic. So that's not a good thing. The traps supposed to be set in their plumb. Max length of tailpiece is typically 24 inches, although for the clothes washer standpipes, you can see that 30 inches for the Uniform Plumbing Code. It can be more for the IRC, but again, state of California doesn't use the IRC, but there are states that do. So if you get outside of California, or if you get in a pinch and you're trying to convince the building inspector that what you've done is okay, they might accept that on a one-time basis. Vents. So the thing to remember about a vent pipe is even though they're carrying air, they're still supposed to be sloped 1/4 inch per foot so that any condensate or anything that gets in there will drain out.
So Larry, if you have a sink that's sitting out somewhere and it's more than 24 inches from your drain line, what are you supposed to do?
That's the tailpiece coming off down to the trap.
Yeah,
So let me see if I can find that picture.
I know, but what if it's longer than that? It's just weird. And you got to set up a new drain line?
Well, I'm sure what's going to happen is you'll go ahead and plumb it however you think is right. And if you need a longer tailpiece, you may put in a longer tailpiece. Generally speaking, while there are some maximums in there, we know that the reality is that there's a factor of safety built into most of that stuff.
Right.
And if the building inspector says it's okay, or their boss says it's okay, then you're good to go.
Right.
But the way it's supposed to be set up, what was that?
Hello?
Sounds like somebody's got a semi. So let me see if I can find that picture. That's not the one. That's not the one.
You're not talking about the trap arm, you're talking about the tailpiece.
Yeah, the tailpiece is the part that comes out from the sink.
I got you.
So here's the tailpiece right here.
Right.
So here,
I was-
that depends on the size of the trap arm. So 1.5 inches, you can go 3'6". 2 inches, you can go 5 feet. And again, the IRC lets you go a lot farther. And so my feeling is most of the time, unless you get a real gung-ho inspector, if you're close, they're probably going to tell you it's okay, or they're going to not mention that it's not quite okay. But
I was confusing the
you do need to be
tailpiece with the
close.
trap arm. I was
Yeah, the
confusing the two.
tailpiece. Yeah, the reason for that is the concern is if the tailpiece gets too long, then that column of waters that's coming down may suck the trap seal out of the trap. It
Got
may
it.
have enough momentum to pull it out. You are
Okay.
supposed to have the slope on here, 1/4 inch per foot, Uniform Plumbing Code. IRC says 1/8 inch per foot. I see lots of them that have no slope at all. They seem to work most of the time okay. Sometimes on these traps, if you have an old sink and you've got metal, a metal trap, sometimes all that's left is the plating that was on there, and the rest of it's been eaten away. So the picture right here, we also talk about a wet vent. And so here we've got a couple of labs. We're coming down, we've got our approved transition from vertical to horizontal, which is this long sweep. But this area in here, we've got it's carrying water and air, and that's a wet vent. There are some rules for wet vents, and I think it's probably right up here. And I'll send you a copy of this. I'm just going to send you the Uniform Plumbing Code stuff, since maybe that'll stop.
Oh, barely.
Maybe.
So wet vent is one that also carries air. Is that what the def?
Carries
is that what-
air and water. So
Okay.
it's going to carry air and waste. And because of that, if you go to a wet vent, the plumbing code says they all have to be on the same floor. The vent itself has to get larger, has to be one size larger than it would normally need to be if it's carrying both waste and functioning as a vent, which is primarily to carry air. And I have no idea why that thing is moving up and down that way. So happy days. And so normally what we have, let me show you a little schematic. Let me get out of here and go back to sharing. So I'm going to send this to you.
Mhm.
And so
Yeah, that'll
this,
be good.
and then we'll kind of walk through it, but I will email this out. So let me see if I can. Make that a little bit bigger. So this is a just a schematic. We've got this for residential. So there's some water closets. So if we look right here, this represents a water closet right there. And so that doesn't have a trap because the toilet is internally trapped. So the trap is built into the toilet. So that just represents the flange over here. We have a shower. And there you do see a trap. We've got a trap arm and that's tying in. Now this one, we have a wet vent. So the VTR, this is the top, that's the vent through the roof. Need a jack for that. So all of those little numbers, there's a chart down below and we'll walk through and try and size everything based on the information that we have on the trap sizes, the DFUs, and we'll go through a little exercise. So this here is what we call a circuit vent, right? It's not in a straight line with the vent. That's why we often have little problems when things get clogged up. But we have a lavatory here. And this little section of pipe in here. So this is wet vented. The plumbing code says if you are going to wet vent in a residence, all of the fixtures need to be on the same floor. So, and there's a maximum distance we can go from our toilet, for example, before we get to a vent. There's a max distance for the lab, which is right there. They're showing the lab. And each one of those has its own trap arm size. So I think the table down below has all of that information. Let me see if I can bring that into view. And so on that diagram, all those little pipe sections, what they want to know is you're going to figure out how many fixture units are on that pipe and what the required pipe size is. And that is fairly simple. For the waste, we start at the top and we work down. So if we look at this right here, the lab, if you look over to the, I don't know, you can't see the table, but I'll take a look at that. And whoops, everything went black.
We can still see it.
Okay, I don't know what happened.
Yeah, I guess you'll see it.
One of my monitors just went out, so. Yeah.
So each one of those labs and water and vents have a value?
Yeah, so the lab has a, what is it? Lab normally is one drainage fixture unit, I think. Let me
Yep.
move this over. I don't have it in front of me right now, but like I said, I had two monitors here and one of them just went black on me. So I guess I'm having some technical problems.
Water closet has 3
Yeah,
DFUs.
lavatory, one drainage fixture unit, bathtub, two drainage fixture units, shower, two, water closet. This says 3, bidet, 1, laundry tub, 2, kitchen sink, 2, clothes washer, uniform plumbing code says 3. And some of this stuff should have changed a little bit, because what's happened over time is originally, I think the toilets had 5.9 gallons per flush. That was the old style toilet.
It's a lot.
And then we went to a low flush toilet, which was 2.9, I think,
1.6
gallons per flush. And then we went to the low flow toilets, which were 1.6 gallons per flush. And now we're at 1.28 gallons per flush for the very low flow toilets, but they really haven't changed significantly the fixture units on a lot of the plumbing fixtures. But as we go down, what happens is there are two ways to design these things. One is you can take an engineering approach. The code takes a prescriptive approach, and we just start at the upstream and start adding fixtures. So at this little section of pipe here, there's 2. That has the 1 drainage fixture unit. By the shower is picking up 2 drainage fixture units. By the time we get down to number 4 here, we have the lab plus the shower. So we have 3 drainage fixture units there. Here.
Yeah, we're not following your pencil anymore. Dude.
Oh, can you see that or not see that?
We can see the VT, we can see the schematic, but we can't, it's not like live anymore. It's like
Okay, let me figure out what's going on. That helps with the lights. Let me get off of here. Let me go back to share.
Yeah, it's moving now.
Now it's moving.
Okay.
Why does the water closet on the right show a 5?
These are just the pipe sections. So this is pipe section 1, pipe section 2, pipe section 3, pipe section 4, pipe section 5. So that goes with the little table down at the bottom. And so I'm going to send this out. Whoops. And so what you'll have is for each pipe section, you'll have the fixture units, and they just add as you go downstream. Now for venting, it's just the opposite. Venting, we start downstream and we start going, well, we have the same basic problem. We have to add those up. But venting, we're typically starting down low and working up. And then at the very end, the aggregate area of all of the vents can't be less than this area the drainage pipe is connected to. Although again, that gets violated quite often. So if we look at just this picture here, 27 is a vent pipe. And so that's going to have all of the fixture units on there. So there's a minimum size for the number of fixture units. But if that's the only vent coming out of the house, then there's a minimum area it needs to be in relation to the building drain. But here, this pipe section here, 24, for venting, it's collecting both the lav and the shower. For pipe section 1, that's just the trap arm. That's just going to be one fixture unit. For 2, that's a wet vent. You see, it's venting. It's providing the vent for the shower, but it's also receiving waste from that lav. So that's a wet vent, and that would have to be oversized. So normally it could be an 1.5 inches, but we're going to have to go up a size to a 2-inch pipe because of the wet venting. If you look at pipe section 4, right, that is collecting the drainage from both the lavatory and the shower. So we'd have the 1 drainage fixture unit from the lav, 2 drainage fixture units for the shower, and this would have 3 drainage fixture units. Over here at 5, that's carrying the water closet, so that would be 3 fixture units. 6 is also, right, we are venting, but it's also taking the waste from that water closet, so that's 3. Whereas by the time we get to 7 here, right, we have picked up the water closet, which is 3. We picked up the shower, which is 2. We picked up the lav, which is 1. And so,
so in number 6 right there, Larry, you're still at 3. You're not.
Yeah.
You have to include 1 for the vent, right? It's just.
You're still at 3
Okay.
because you haven't picked up anything else, right? That's above the connection for that pipe 4, which
Right.
carries the 3 fixture units.
Okay.
So, but
Got it.
I will send this to you first so you can look at it and play around with it, and then we will kind of walk through it as an exercise. Gesundheit. Somebody sneezing,
you.
coughing?
Somebody's
I'll run you
sneezing.
through that.
And so the dotted lines in your schematic that's the venting.
Those are the vents.
Okay.
So those are the vents. And again, you got a little piece of
I got you.
pipe there that is wet vent. So the ones that aren't a continuation of a drain line, those are circuit vents. And that's what
if
they're
they're all
doing here.
interconnected, wouldn't they all be a wet vent since they're all intertwined and connected together?
No,
No? Okay.
no, we have to look at how they're routed. So see,
Okay.
some of these are just straight circuit vents, and this one, see, this isn't connecting here. This is coming over here and coming up and avoiding all of the drainage from the fixtures above. You can't see. If we pull down,
Okay.
see how this one that's here, 23, 22, 20, so that's all vent. It's not receiving any waste.
Okay. I just was wondering, since they're all tight, since it looks like it's all drawn into one main vent, I mean, if they'd all be considered a wet vent, but okay.
No, the plumbing code doesn't consider, a wet vent is one that actually has water in it, has liquid in it.
Okay.
So you've got waste in it. So if you look at this point right here where my finger is, and
Right.
you look at 20, and you go up to 22, there's no drainage coming into the pipe.
Got
And
it.
if we go up higher above 22 to 23,
Right.
see, there's still no drainage going into that pipe.
Okay.
And then that ties in. So here's 23, and that ties in over here. And we still have no drainage coming into it, and then it's up and out.
Gotcha.
And so that is a normal vent. And high
Oh, the
rises,
circuit
they
vent.
use, they have some specialty stuff. They have a copper Sovent system, and it's a little more sophisticated. You also have yoke vents and pressure relief vents in high-rise buildings that is kind of beyond the scope of what we're doing here. Now, so, and again, CO is clean out. This is a backwater valve. So this is 2 floors. I don't know. You can't really see it real well, but we've got an upper floor and we got a lower floor, but I'll send you the picture. And so the lower floor in this case is below the sewer out in the street, or at least below the manhole rim. What happens is, you may be below or above the sewer. However, you may not be below the manhole. And so as long as you're above the sewer, sewage under normal circumstances will flow. If sewage backs up in the manhole, then you have a head of sewage. Then you may go from being above the sewer line to below the manhole, the flooded manhole rim, and then sewage can get back in the house. And so that's what a backwater valve is for, is to take care of that particular problem. And
I hope that clean out is above the sewer line.
yeah. So again, these are just schematics.
Yeah, I got you.
So normally the plumbers refer to those as artist misconceptions. Because what happens is, remember, on residential construction, we don't have normally plumbing plans.
Never. There's plumbing plans. You got to make it up on your own.
Yeah. Let me get rid of that for a minute. Go back to our plumbing stuff. Yeah, so I mean, part of it is, it depends on what parts the plumber has on hand and whether or not they want to go get more parts. A lot of times the drawings will show a straight run, and instead of a straight run, you're going through a footing or some other obstruction that nobody told you about, or in the middle of a swimming pool or something else. So quite often things wind up getting rerouted in kind of a Rube Goldberg sort of way, not very efficient. The plumbers do the best they can, but even in commercial, they want a schematic. So commercial work, you'll do a schematic. The plumber still has the same problems, because often the location of where the plumbing lines are supposed to be, that's not how they were actually put in. And so out in the field, what gets installed often bears no real resemblance to what the original plan was. Sometimes the building inspectors will send them back, but most of the time, as long as it complies with the plumbing code, they're happy with it. They're not going to send it back for that. So here's our drainage fixture units. We also have WFUs, water fixture units, but water fixture units are not the same as the drainage fixture units. So there's a little bit of a break there. I'll send you both tables, but I'll send you the table out of the plumbing code rather than this one, because it's more inclusive. This is just for residential. For commercial, they'll have a standard DFU, and then if it's a public facility, or they're expecting a lot of use, then they have a higher fixture unit count versus these that are considered to be private. So, and you know, here do you see a floor sink in here
Floor
on
drain, no.
this table 14? No. So those that will be in the table from the plumbing code. So I'll send that out. Same with the water fixture units.
Cool. Yeah,
And you know, in a commercial kitchen, we have service sinks, and then you know, you can get into some specialty type things too. But vent termination, so there's a requirement on where the vents terminate in addition to the sizes, which we'll go through a sizing exercise. We've got, it's got to be 6 inches above the roof. It's got to be at least 12 inches away from vertical surfaces in the Uniform Plumbing Code. You have to be at least 7 feet away from a walking area. Again, remember the vent is there for 2 purposes. One is to allow air to flow through the system. And so you can try this if anybody still have a straw, they still making straws?
yep.
They make those paper straws that turn into something other than a straw after about 10 minutes. But so if you stick your straw in a drink and put your thumb over it and lift it out, you'll pull out a column of water because you have air pressure pushing up on it. So if you don't have a vent that's open, you know, the water may not flow. So that's one purpose, is to make sure that gravity can do its job. The other is those gases in the sewer, as I said, are nasty. They can be corrosive. You know, the concrete gets eaten. The hydrogen sulfide mixes with water and you get sulfuric acid condensing in the sewer. So normally what happens is they'll paint or coat the crown of the sewer, which is the top half, because sewer normally is not running full. It's only running partially full. The sulfuric acid in vapor form is up there and it attacks the top of the pipe and will eat it away. Clay pipe is good for that because the clay, when they fire it, vitrifies or forms a glass lining. And the glass is more or less impervious to most acids, not all acids, but most acids. And then we don't care about island sinks. So this is a Uniform Plumbing Code way to vent an island sink. Now, and these days, if you watch that Do It To Yourself network, if you're remodeling or you're buying a new house, you have to have an island sink or an island of some sort. Typically, you have a stove or a sink in there. And this is the way you vent it. You can't run the vent up because most people I won't say you can't, but most people don't want to see a vent pipe coming up out of their island. And so there is an approved or a proper method for doing that. So here we have our sink. And notice there's a little gap between the spout on the sink and the flood rim of the sink. That's called the air gap. And that, again, is required by code. We've got the tailpiece coming off of that sink. You've got the trap arm. And then you're going into that vent. Uniform Plumbing Code, they run it up at 45 degrees. I'm not quite sure why. You have to put in a clean out either above the floor, or if it's if you're on a raised wood floor, you can put it below the floor. And then they require that foot vent, which is the one that comes off just below, they're showing just below the floor line and coming up, and they're calling for a clean out in that foot vent. So that's the Uniform Plumbing Code method. And I don't know if they've got the IRC allows a little simpler. They just let you come up with a 90 here and a 90 over here, and they have a straight piece of pipe in between them. So the plumbing is a little simpler for the IRC where that's enforced.
So hopefully you have enough air pressure pulling from the regular vent to pull all that air that's trapped up in there out. Is that what the?
Well, it's not going to get trapped up in there. You're providing, right? Remember, we can go a certain distance before what they're requiring is this foot vent though, to make sure that you've got air getting into the system. The fixture itself acts as a vent, right?
Right.
It's acting as a wet vent. So you pour water in here, this is open to the air.
Right.
The water runs down, you get the little trap seal at the bottom. If you let it sit there for a while, sometimes you'll notice it gets pretty stinky.
Yeah. No
Things
water.
starts to smell bad, starts to smell like rotten eggs. And that's the hydrogen sulfide is soluble in water. And so you can run some water down there. You can throw a lemon down there or some something similar to try and change it. But after a while, if you're not using it regularly, then it's going to get stinky. And that's just because those sewer gases are dissolving in the water. And some of that odor then is coming up from the trap. So, but, you know, if air gets trapped in here, then you're going to pull a vacuum and it won't be able to flow properly.
So that's all that's in that top pipe where where the 45s and it says 1.5 on both
Yeah,
sides.
that's
all
just
air,
to get,
right?
yeah, that's just to get you over. Hopefully you're at or above the flood rim or the overflow in your sink, which most sinks will have an overflow.
Right.
So the idea though is you want air to be able to flow freely. And so this is more of a insurance, I should say, that you're going to be able to get air into this system.
So is that considered a wet vent or a circuit vent?
This is neither.
Neither.
This is
Okay.
the island sink vent.
Okay.
So,
Okay.
so you know, this is technically, you know, this is your waste pipe here, but it's also at least partially going to act as a wet vent.
Got it.
But you're not going very far before you're bringing air into the system. So just as we can go some minimum distance before we have to get to a vent, this is just a method of trying to make sure that you're not going to be working on that island sink all the time when it gets clogged up. What else? Air admittance valve we've talked about. And so we haven't talked too much. This is the air admittance valve. So the air admittance valve, we discussed, I believe, once before. So that's a one-way valve that lets air in, but it doesn't allow the sewer gases out. And this is used in a location where you can't readily get a vent to the roof or a vent to the outside installed. So most common place I see these is in remodels. Sometimes the building official will let you use those. Uniform Plumbing Code does not recognize those, but some of the other plumbing codes do. And we haven't talked about water pressure, but I will send you out a copy of the water fixture units too. Minimum water service size is supposed to be 3/4 of an inch, but in the city of San Diego, that's now 1 inch. And the reason for the 1 inch is because the houses all have to have a sprinkler system now, the new ones. And so they've upped that for the sprinkler system. So this says 3 bathrooms usually means 1 inch service. I don't know if that's really true anymore because we've gotten to those, low flow fixtures here in California. And so I'm not sure that that really makes a lot of sense, but 1 inch service is what you're required to have anyway.
So is that the service coming from the city or?
Yeah, that's coming from the city. So if you want if you're going to put in a water service, normally you go to the engineering department and they give you something called a water service data card.
Right.
That water service data card gives you both the maximum and minimum static pressure at the meter, because the water pressure goes up early in the morning. It goes down when people are getting ready for work. By early in the morning, I mean 2, 3 o'clock in the morning, the water pressure goes up. Not a lot of people using the water. And then during the day, during periods of peak demand, the water pressure drops. And so what they're looking at is plumbing code says you need 15 PSI for your fixtures to operate properly. And if you're not going to be able to get 15 PSI, then you may have to put in a booster pump. And you can get a pump installed in the line and to kick the pressure up. Usually in the city, that's not a problem. Some places you have very high water pressure. Gillespie Field, their minimum water pressure is 110 PSI. And that's because the airport is down in a hole and the water tanks are pretty high up on the hills. So they get good water pressure in those locations. If you're over 80 PSI, you need a pressure regulator. And I just had to replace my pressure regulator because normally after a few years, they quit working. They calcify up and they're no longer doing the job they're supposed to. We talked about all that. That's all regular stuff. So used to all be copper. Now for the meter to the house is usually plastic. And that's okay.
What was that?
If you have an old house, you'll have a copper service from the meter to the house. A new house, generally you're going to have plastic. It'll be plastic from the meter. You'll have a transition riser at the house, and which is also why we used to use the copper water pipe coming out of the house as the ground, and because it's plastic now,
they even come in colors. They have the red for hot and blue for
yeah, that's the PEX. So that's usually inside the house. That's the PEX. But remember, it doesn't matter what color the pipe is if they hook them up to the wrong side of the system.
Yeah, right. Yeah.
So if you see the red on the right and the blue on the left, either they've got the pipe in backwards, or they've put the hot water in the wrong place. So according to the plumbing code, the hot water should be on the left and the cold water's on the right. And that's a safety feature. We've had a lot of issues. The people that normally get burned or scalded are kids and old people. And that's because people just drop the kid in the water sometimes and don't test it. And when you get older, you're slow to react. It takes you a while to figure out that you're getting boiled alive. So,
it's not funny, but it's true.
Yeah, it's not funny, but it is true. So the showers now, pardon?
Never mind.
No. So, nowadays, if you put it in a shower, you have to have a valve in there that prevents scalding. So it may shut off the water entirely if there's too much, if there's no cold water and all you're getting is hot water. But there's a hydrostatic mixing valve in there to keep people from getting burned. And that's because I think attorneys have brought enough lawsuits that's now required. So my house, which was built in '59, you can have pure hot water coming out, and that is no longer permitted. So whether that's good, bad, or indifferent, I don't know.
In restaurant
Good if you want really hot water, but
I think the water has to be a certain temperature.
Yeah, there's a max temperature and a minimum temperature, but if you look at a meat thermometer, usually at around 120 to 140, you're starting to cook stuff. And so I think it's about 120 is where people start to burn. And if you've ever dealt with burns or seen people that have had severe burns, those are pretty nasty and leave some pretty ugly scars. So
very
one of those
painful
things.
recovery.
Yeah. So I think, let me see what time it is. Oh, there we are.
7:38.
Yeah, we're about there, and I'll stop the recording.